This is our final lesson on how to solve equations and inequalities, and this lesson is about equations and inequalities that have rational numbers. So on your screen and on your notes sheet, you will see that we have this diagram from the beginning of the school year where we learned that the real numbers are split into rational and irrational numbers, and today's lesson is talking about rational numbers. Underneath rational, before we got down here to integers, whole numbers, and natural numbers, there were two types of specific numbers that we called rational, and they were terminating decimals and repeating decimals. Now, the other thing we learned at the beginning of the year were fractions, decimals, and percents that were equivalent, and we learned that terminating decimals are decimals that end, and they can be written as fractions. So one of the decimals that you had to learn and memorize as a fraction, excuse me, that was a terminating decimal was the fraction 1/2. 1/2 is 0.5. That's a terminating decimal. 4/5 is 0.8. That is a terminating decimal. You also learned repeating decimals could be written as fractions. You learned, for example, 1/3, which is 0.3 repeating, and you learned all of the ninths, like 7/9, which is 0.7 repeating. So in this lesson, we're going to be seeing both decimals and fractions. That's what we're talking about when we say rational numbers. So a quick refresher on the word inequality. Inequality means not equal. This prefix in means not. Like inappropriate, it means not appropriate. So inequalities have four symbols that you're very familiar with: greater than, less than, greater than or equal to, less than or equal to. So I'm going to go ahead and put in my balance line. And it says solve the inequality by clearing the fractions, and we learned how to do that in a previous lesson. I know that I'm going to multiply both sides by a whole number, and I need to look at the denominators to decide what whole number to use. I'm looking for a number that these denominators will go into. So I want to use maybe 27, because 3 would go into 27 and 9 would go into 27. But there's something I could use that would be even smaller, and that would be 9. 3 goes into 9, and 9 goes into 9. So I'm trying to use the least common multiple. I'm going to copy my symbol there, and I'm going to work on this side first. I am going to remember that I can cancel this 9, or not cancel, excuse me, but I'm going to rewrite it as a product. 3 times 3 is 9. And the reason I would want to do that is so that I could cross out a 3 from the top and bottom. 3 over 3 is 1, so all I've done here really is divide by 1. And what is left? I've got 3 over 1, which is just 3. Now I know some of you can do this in your heads now, which is excellent, but I always want you to know a way to solve it without doing it mentally in case you get stuck. So on this other side, I'll go ahead and I'll turn this 9 into a fraction, and I know that when there's a number right next to these parentheses that I need to distribute. On your paper there should be a plus sign there. So here we go with distributing. I'm going to distribute this and multiply these, and I'm going to distribute and multiply these. So I know that I've only written this 9 over here one time, but it's actually being used twice. That's what distributive property means. So in other words, I'm doing 9 times 5/9, and that was negative. And I'm also doing 9 times 1/9. And that's the part that can get a little bit confusing, is thinking that that 9 is only going to that first number. Well, if I turn that 9 into a fraction like I've done there, watch what's going to happen. I chose 9 for a reason. I chose 9 because I knew it would cancel out. there's a 9 here on the top and bottom. So that's going to leave me with just negative 5 over 1, which is negative 5, and then the x is there. And on this one, actually, these are multiplicative inverses or reciprocals. 9 on top and bottom, again, I'm just going to be left with a 1, and it was a plus 1. Now this is a two-step inequality that you guys are very good at solving. I'm going to go ahead and finish this one as a model. Circle the variable with its coefficient. So I'm circling x with its coefficient of negative 5. And what is the inverse of plus 1? Minus 1. What I do on one side, I must do to the other. That's why that balance line is there. This becomes 0. It's called a zero pair. And I've got negative 5x is less than 2. And my final step is to divide both sides by negative 5. Now this is where you had to remember something from our previous lessons on solving inequalities. When you multiply or divide by a negative number, this middle symbol is going to have to change. This will become a giant coefficient of 1, so I've got 1x, which I'll just write x, and this will be 2 over negative 5, or negative 2/5. But what changes, and I'll go ahead and do this in a different color, is this symbol, the inequality symbol had to switch the other direction. So my graph would then look like this. X is greater than, so I'm going to have an open dot, and it says greater than. Here's the greater than numbers, and that would be at negative 2/5. You could always go one step further and write this as a decimal. This is one that you know, 0.4. And then you could add a number on either side. I would like you to add a fraction on either side and also add a decimal on either side. On your note page, please bring it to class tomorrow. Now we're going to talk about working with decimals in these type of equations and inequalities, and I want to do a quick review on multiplying by powers of 10. If I have 1.589 and I multiply it by 10, let's use a calculator really quick because this is such a tough problem. 1.589 times 10, it's 15.89. Okay, so let's see, 15.89. Well, how did that change? Well, it looks like I just moved the decimal one time from here to here. There was 1 0. That means I'm moving one place. So instead of getting out my calculator, you saw how long that took. I know that I'm going to have to move this 2 places. So I bet this answer is 158.9. And this next one, it looks like I'm moving the decimal 3 places, which is going to take me all the way to the end of my number. Now I've got 1,589. And this last one, 1, 2, 3, 4 times, well, that's going to take me all the way to the end of my number. And I'm going to have to add one more space, which means I've got room for a 0 back there. Now I've got 15,890. You guys definitely don't need a calculator for that. I was trying to make a point how long it took me to get out my calculator when I could have done this in my head. So the reason we're reviewing this is so that when we see a problem like this, we don't have to work with the decimals. You guys know how lazy I am, and I don't want to work with decimals if I don't have to. So here's what I'm going to do. I would need to move one time to turn this from 3.9 to 39. So that would be multiplying by 10. I would need to move this one time to turn it from 2.6 into 26. That would be multiplying by 10. But on this one, I would need to move this decimal twice to turn that into 156, which means that I'm actually going to have to multiply both sides by 100. 100 will get rid of all of the decimals. Let's start on this side. Just like I did on that previous page, I'm multiplying by 100, which means the decimal is going to move 2 times. So once, twice. This is now negative 390. Yay, no more decimal. It's a whole number. I love whole numbers. On this side, I know I'm multiplying this whole side by 100. That's where the distributive property happens. Both pieces will get multiplied by 100. So I'm going to multiply by 100. That means move 2 times. 1, 2. I've got room for a 0 there. So now I've got 260x. And this one was the reason I had to multiply by 100 when I moved this twice. It is no longer 1.56, it's now 156. Now this is an equation I'm confident you guys can solve. You are great at solving these type of equations. You're going to begin by circling the variable and its coefficient and continue to solve that problem. And our final example is the same idea, except now we have an inequality symbol. So I'm going to do that same process that I did before. I know I'm going to have to multiply this side by something, and I'm going to have to multiply this side by something. I would have to multiply this by 10. This is already a whole number, so I wouldn't really have to do anything to that. But this one I'm going to have to multiply by 100. So since I have to multiply one side by 100, I have to multiply the other side by 100. That's why we always draw the balance line. This symbol hasn't changed because I multiplied by a positive here. And this 5.64 is now 564. Great, it's not a decimal anymore. And I need to distribute this 100 to both pieces on this side. Well, 100 times 3, that's 300. I'll go ahead and do that one right away. Pretty easy. And 100 times this, well, I'm going to move the decimal 2 times 1, 2. I'm going to have a 0 there. Negative 470x. I'd like you to go ahead and finish this problem. I want you to be careful, though. I will let you know that at the end of this, you're going to end up dividing by a negative, which means this symbol at the very end is going to flip the other direction.